Okay, so we're looking at mixed exercise 5 from the first year core textbook. So we're on straight line graphs. Question 14, so it's an exam question, so we can see how many marks each part's worth, and they're all only worth 2 marks, so hopefully none of the individual bits should be too bad. So I've got an equation of line 1, I've got an equation of line 2, and the first thing I need to do is sketch them. Okay, so with a sketch, so you don't even need to pick up a ruler, as I'm demonstrating on my sketch here, but everything needs to be labelled, including intercepts. I mean, it normally clarifies what they want you to show, but always assume that if you're sketching a graph, you should be showing the coordinates of the intercepts, not where they intersect each other. That would be a separate thing, which they might ask us to do. Okay, so let's start with line 2, because that's in the form y equals mx plus c. So I've got the luxury of being able to use colours. So that's line 2. So y equals 2x minus 3. So it cuts the y-axis at minus 3, and it cuts the x-axis where y is 0. So I just quick bit of solving there. So that's 3 over 2. And you watch out for, should it be positive, should it be negative? Because then it should be obvious if you've made any slips. Okay, so then here, well, I've got a few options with line 1. I mean, one would just be to rearrange it. So 4y, so minus the x from the right-hand side, and then divide through by 4. So that's a straight line with a gradient of minus a quarter going through the origin. And then I should also just make sure that obviously it's going to be sloping the opposite way to this line, but it's a good idea. It's obviously significantly less steep as well. So let's do it in a different colour. So I'll just try and show that. So we've got a negative gradient. Okay, that is a mess. Let's try that again. Okay, so I've got a negative gradient, and it's going through 0, 0. So that's line 2, which was 4y plus x equals 0. I mean, your other option, that you could have figured it went through 0, 0 just from subbing x is 0 and y into 0 into that as well. So that would have been the alternative to rearranging it. Okay, so I think we've got part A covered. Oh no, yeah. I mean, well, I tell you what, I don't need to do this, but that's as long as it's clear it's going through the origin. I reckon I'm right there, but just in case. Okay, so lines intersect at point A, find the coordinates. Yeah, so we're sort of expecting that. So assuming my sketch is correct, I'm expecting that to be a positive x coordinate and a negative y coordinate. So let's write the 2 equations out, and I'll go back to sort of the unrearranged forms, just in case I've done anything daft. Okay, and I think for that particular one, my preferred method is just going to be to substitute 2x minus 3 in for y. So that will become 4 times 2x minus 3, and I've got plus x equals 0. So 8x minus 12 plus x is 0, so 9x, and then if I add the 12 over, I will get x is 12 over 9, or 4/3. And then obviously I want the coordinates, so I'll go back to this equation and say, well, so y is 2 times x, and x is 4/3 minus 3, so y is 8 over 3 minus 3, so I think it's going to be minus 1/3. So my coordinates would be 4/3 minus 1/3. And as far as I can judge from my sketch, that seems okay. Obviously, this isn't drawn particularly to scale, but x should be positive and y should be negative. What were we calling that? We were calling that A, so I think it should be obvious that's my answer, but let's just clarify that that's A. Okay, so calculate as exact fractions. Yep, we did that. So find the equation of the line through A, which is perpendicular to line 1. Okay, so it's going through this coordinate. Oh, to cross that out, I meant to highlight it. Right, so it's going through this coordinate. I need the gradient. It's perpendicular to line 1. So there's line 1. Well, we'd already looked at the gradient of line 1 here. So if it's perpendicular to a gradient of -1/4, it's going to have a gradient of 4. Okay, so that's perpendicular to a gradient of -1/4, which is the gradient of line 1. Right, so nothing too bad to just finish this question off. So I'm going to use y minus y1 is m times x minus x1. So there's my gradient. There, oh, for goodness sake, there's my x coordinate, and what have I not used? There's my y coordinates. I'm just going to be careful that I don't miss the fact that's -1/3. So y, oh, right. So y minus -1/3 minus -1/3 is my gradient times x minus 4/3. They wanted it in a particular form, I think. Yeah, they wanted a, b, and c to be integers and everything to equal 0. So let's lose these brackets and then we'll worry about the integer part. So y minus -1/3 is going to be y plus 1/3. It's going to be 4x minus 16/3. So I'm just going to multiply everything through by 3 before I even worry about rearranging. And then they want everything over to the left-hand side. Okay, so just double check. I think, yeah, it's not going to matter that I've got my x term first and they've got their y, I've got my y term first and they've said x first. As long as everything's on the same side equal to 0 and everything's integers, that's fine. But alternative would be to either just rearrange the order or even multiply everything through. So either of those would be acceptable. I think, as long as they're the correct answer. 12x minus 3y minus 17. We got that, and yet we got the 3 coordinates labelled, so that's all we need.